Hi, sixth grade. This is Mrs. Guido, and I will be reading the text for Discovering Density with Archimedes. The overview. Archimedes discovered that fluids, such as air or water, apply an upward force on objects that are partially or totally submerged in fluids. The upward force of the fluid is called a buoyant force or buoyancy. A buoyant force is equal to the weight of the fluid that the object displaces. This natural law is called Archimedes' principle. A heavy ship can float on water because it is not solid throughout. Instead, the ship has many hollow areas filled with air. This means the ship has its mass spread over a larger space or volume. If the ship were compressed or pressed together into a solid block, it would still weigh the same, but its volume would be much less. This means there would be no hollow areas filled with air. The smaller solid block of metal would displace less water than the large hollow metal ship, and its buoyancy would be less. Therefore, it would sink. Sink or float. Whether an object sinks or floats in a fluid, liquid or gas, depends on several variables. 1. The density of the object in a fluid. 2. The density of the fluid the object is floating in. Fluids with higher densities can produce a greater buoyant force, allowing objects with larger densities to float. If the density of the object is greater than the density of the fluid, the object sinks. If the density of the object is equal to or less than the density of the fluid, the object floats. The story of Archimedes. Before the Greek mathematician and inventor Archimedes, nobody knew why some things floated and others did not. It is said that Archimedes' king gave a silversmith a certain amount of gold to make him a new crown. When the crown was finished, the king asked Archimedes to figure out a way to secretly determine if the crown was made of pure gold or a mix of gold and cheaper metals, as the king suspected. Archimedes was puzzled as to how to do this until he stepped into a bathtub and observed that his body displaced, or pushed out, a certain volume of water from the tub. Two objects cannot occupy the same space at the same time. His body pushed out the water, equal to his body volume, to make room for him in the tub. Gold would do the same thing. Gold has a specific density, or mass per unit volume. This means that there's a specific amount of gold material in a given volume. Archimedes realized that he could determine the volume of the crown by measuring the volume of water displaced by the crown. Using the volume and the mass of the crown, he could determine its density. It is said that he was so excited about his discovery that he ran naked through the street yelling, "Eureka! I have found it!" I have my doubts about this, but who knows? He tested the crown by placing it in water and comparing the displaced water of the crown to that of known displaced amounts of water from pure gold. He determined that the density of the crown was not that of pure gold, and the silversmith who made the crown was killed for stealing from the king. Whether this story is true or not, Archimedes did discover a technique for determining density using water displacement. Part 1. Defining the concepts. Using the information above and your knowledge of density, answer the following questions. What is density? And what is buoyancy or buoyant force? At this point, if you're still watching the video, please pause and go back to your text and find the information to answer these two questions. Then push play when you're ready to continue. Part 2, practice. You're going to complete the table below. As you can see in this table, you have a chart that includes cube materials. These cube materials read aluminum, brass, steel, copper, acrylic, oak, nylon, pine, poplar, and PVC. You're going to make qualitative observations. You're going to find the mass of each cube. You're going to find the volume of each cube, and you're going to calculate the density. The next section should look familiar from our notes for this section of the activity list. Looking at your results, draw and label where you think each cube would be placed in the bucket of water shown below. Please pause, and I want you to show us, using a drawing, where each cube would be. For part 3, applying and practicing your knowledge of density. Complete all the questions. Please make sure you're showing all your work and using the correct units. Question 1. State the formula for density in words or mathematical symbols. Question 2. A rock has a mass of 210 grams and occupies a volume of 70 cubic centimeters. What is its density? Show your work and make sure your final answer has a unit. Question 3. An unknown liquid occupies a volume of 5 milliliters and has a mass of 40 grams. Find its density. Show your work and make sure your final answer has a unit. Question 4. A rectangular solid of unknown density is 5 meters long, 2 meters high, and 4 meters wide. The mass of this solid is 300 grams. Given this information, calculate its density. Show your work and make sure your final answer has a unit. Question 5. Tap water, what comes out of your sink, has a density of 1 gram per milliliter, and ocean water has a density of 1.025 or 1 and 25 thousandths grams per milliliter. What makes ocean water more dense than tap water? Question 6. A graduated cylinder has 20 milliliters of water in it. An irregularly shaped rock is then dropped in the graduated cylinder, and the volume of the rock and water in the cylinder now reads 30 milliliters. The mass of the rock dropped into the graduated cylinder is 23 grams. Find the volume of the rock dropped into the graduated cylinder. Find the density of the rock dropped into the graduated cylinder. And then an optional challenge, reading density graphs. Use the graph below to answer the following questions. What is the density of object A? Does it sink or float in water? What is the density of object B? Does it sink or float in water? And what is the density of object C? Does it sink or float in water? When you have finished and reviewed your work, you're going to submit this to Schoology. Again, please make sure as you're working, you're pausing the video and working on a specific question and then pushing play to continue. Bye.